Good day everyone. Today we will see how to prove two lines intersect, and if they intersect, how to find the point of intersection. If the point of intersection is not asked, you can actually do. If the shortest distance between the two lines is equal to 0, you can say the two lines intersect, right? If the shortest distance is not 0, you will say the two lines do not intersect. But if you are asked to find the point of intersection also, you cannot find using that method. So now let me teach you one method in which you can prove that they intersect as well as you can find the point of intersection. You all know when two lines intersect, there will be one common point, isn't it? That is what we call point of intersection. So if we prove there is one common point for the two lines, we can say the two lines intersect. That is what we are going to do now. Now see this sum. Prove that the two lines through A 0, minus 1, minus 1 and B 4, 5, 1 intersects. The line through C 3, 9, 4 and D minus 4, 4, 4. Also find the point of intersection. Instead of giving the equations of the lines AB and CD, they have given you the points A and B. You have to find the equation of line AB. Similarly, the points C and D are given. You have to find the equation of line CD and then we have to proceed. Okay. So now, let us write now. A is 0, minus 1, minus 1. B is 4, 5, 1. Let us find the equation of line AB. You know the 2-point form, isn't it? When x1, y1, z1 and x2, y2, z2 are given, you know the equation of that line will be x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Let us use it now. Let this be now x1, y1, z1. Let this be x2, y2, z2. So the equation I will get here, x minus 0 by 4 minus 0, that will be 4. Y plus 1, 5 minus of minus 1. So I will get 6. That is equal to z plus 1 by 1 minus of minus 1. I will get 2. Okay. So this I will call as equation 1. Then let me write C. That is 3, 9, 4. And D is minus 4, 4, 4. So let me write the equation of CD also in the same way using the 2-point formula. So now I will get x minus 3 by minus 4 minus 3, which is minus 7. Y minus 9 by 4 minus 9, which is minus 5. Z minus 4 by 4 minus 4 is 0. Let me call this 2. So now I have got the equations of the two lines. Now what I am going to do is, I will find any general point on line 1 and I will try to see whether that lies in the second line. Then I can say there is some common point and hence I will find the point of intersection. This is what I am going to do. So now I will take that equation 1, that is x by 4 is equal to y plus 1 by 6. That is equal to z plus 1 by 2. I will equate it to some constant of proportionality k. So now I can find any general point, right? Any general point on AB that will have coordinates. You will get 4k, 6k minus 1, 2k minus 1. So this is any general point on the line AB. Now what I am going to do is, if I substitute these values in equation 2 and it satisfies, then I can say this lies in that line also. Let us see how to prove. Now I will substitute in line 2, right? these coordinates I am going to substitute in line 2. So I will get now 4k minus 3 by minus 7. Actually that should be equal to 6k minus 1 minus 9. So I will get minus 10 by minus 5. That will be 2k minus 1 minus 4. So I will get 2k minus 5. Okay, divided by here I have 0. So now for that k, if I get the same value, actually there are 3 parts here, right? Now I will equate first these two. I will find the value of k. I will equate this and this. I will find the value of k. I will equate these two and then find the value of k. If I get the same k value, that means for that particular value of k, the point, this is a common point for both. That is what I am going to do. Okay. So now first let me take these two. I will write 4k minus 3 by minus 7 is equal to 6k minus 10 by minus 5, right? So let me cross multiply now. What will I get now? Minus 20k plus 15, that will be equal to minus 42k plus 70. Bring the k here. I will get 22k, that is equal to 70 minus 15, that will be 55. By 11 this will go 2 times, this will go 5 times. So the k will be equal to 5 by 2. So this is what I get when I take this and this, right? Now let me consider these two. So 6k minus 10 by minus 5 is equal to 2k minus 5 by 0. Cross multiply, you will get 0 is equal to, okay. So here you will get minus 10k plus 25. So I will get 10k is equal to 25. So k is equal to here also 5 by 2 I am getting. Now let me take the 1 and 3, this and this, right? So I will write 4k minus 3 by minus 7. That is equal to 2k minus 5 by 0. Again that will be 0. So I will be get here 0 is equal to minus 14k plus 35. So 14k is equal to 35. By 7 it is 2, by 7 it is 5. So k is equal to 5 by 2. Definitely you have to take all the 3 pairs. Then if you get the same k value, that means for k is equal to 5 by 2, there will be one common point which will satisfy or which will lie on both the lines. So we can say the 2 lines intersect. Supposing even in one case you are not getting the same k value, that means the 2 lines do not intersect. Okay. So now I have got the same k value. So for k is equal to 5 by 2, there will be a common point. There will be a common point. Hence AB and CD intersect. I have concluded. Now to find the point of intersection. Okay, I know the point of intersection is that 4k, 6k minus 1 and 2k minus 1, because that only I substituted in the second equation also. So let me put k is equal to 5 by 2, 4 into 5 by 2. So I will get 10. Okay. Then 6k minus 1, 6 into 5 by 2. So 15, 15 minus 1 is equal to 14. 2k, that will be 5, 5 minus 1 is 4. So this is the common point and this is the point of intersection between the lines 1 and 2. Is it clear to you? Actually, if you want, you can do in another way, that is, you can equate the first line is equal to some lambda. You can equate the second line to some mu. You will get the general point on the first line in terms of lambda. You will get the general point on the second line in terms of mu. Then you can equate the x coordinates. You can equate the y coordinates. You can get the value of lambda and mu. And then you can substitute in the z coordinate and check whether you get the same point. That is also another way. But this is a bit easier compared to that. So I taught you this method. Okay. So now let me briefly tell you what we have done. We know the equation of AB and CD that we have found by 2-point form. Fine. Now you take one line. I have taken AB. I am equating it to some k or lambda, whatever. I find any general point on that line AB. That I am substituting in my line 2. When I substitute, I get everything in terms of some k and some numbers. Then what do? I equate these two and get one value of k. I equate these two and get one value of k. And from 1 and 3, I get one value of k. If I get the same value of k, that means for that particular value, the two lines intersect. So I can say they intersect. Then to find the point of intersection, substitute that value here and then you are getting the point of intersection. Hope this is clear to you. Thanks for watching the video. You can subscribe to the channel and click the bell icon to get notification of further videos.